Hey everyone, this is the Chapter 1 review video. In this video, we will cover three main topics: units, unit conversions, and significant figures. First topic is our physical quantities and units. In this course, we're going to see many physical quantities. We need to know the symbol and the SI unit for these quantities. The first one is time. The symbol is T. And the unit is seconds, S. Distance, the next one, the symbol is X, and the unit is meters, M. Mass, the symbol is M, and the unit is kilograms, kg. Speed, the symbol is V, and the unit is meters per second. Acceleration, the symbol is A, and the unit is meters per second squared. You absolutely need to memorize the top three. Other units you can derive once you know the equation for that quantity. Another skill that you must have is being able to plug in units when you're given expressions that have different physical quantities. For example, xv divided by v squared, what's the unit? Let's go ahead and plug in all the units. X, we're going to have meters. V, we're going to have meters per second. We're just plugging in the units. Divided by v squared. So v is meters per second. And then we want to square the whole thing. Now we want to go ahead and simplify. Meters times meters per second is meters squared over second. Meters per second squared is meters squared over second squared. And now go ahead and multiply by the reciprocal. Meters squared over seconds times seconds squared over meters squared to get rid of that fraction. And let's see what we're left with. Meters squared cancel out. One of the seconds cancels out. We are left with seconds as our unit. That is definitely a skill that you want to have, being able to plug in units for different quantities. Next up is prefixes. A lot of times, quantities that you are given will have prefixes in front of the unit. When that happens, you want to be able to substitute the power of 10 for the prefix. That means that you need to know what the symbols are for the different prefixes and what the powers of 10 are. So the prefix kilo, the symbol is K. That means you'll see a K in front of the unit. That prefix stands for 10 to the third. Centi, the symbol is C. That prefix stands for 10 to the negative 2. Milli, that symbol is M. That prefix is 10 to the negative 3. Once again, you absolutely want to memorize these three. Other prefixes that you encounter, you will see them on your equation sheet and you do not have to memorize them. Let's do an example. Let's say you see 3 kilometers and you need to use this number in an equation. We want to get rid of that prefix by substituting the power of 10. We're going to write 3 kilo is 10 to the third. So multiply by 10 to the third, and don't forget your unit of meters. You can go ahead and expand it out to get 3,000 meters. Since you can't plug in prefixes in your calculator, make sure that you can substitute the power of 10. Next up is unit conversions. When quantities do not have the correct unit, you want to go ahead and convert them to the correct unit by multiplying the given units by a conversion factor. One thing to keep in note, if your unit is squared, you want to square the prefix as well. If a unit is cubed, you want to cube the prefix as well. Let's do an example. Convert 1 meters cubed to centimeters cubed. Always start all conversions by writing down what you are given, meters cubed, and then figure out your conversion factor that you're going to multiply by. In this case, it involves knowing the prefixes. We know that centi means 10 to the negative 2. So we can put centimeters on top and then replace that prefix by power of 10. 1 centimeter means you have 10 to the negative 2 meters. That is a conversion factor. Those two are equal to each other. Now, in order to cancel out meters cubed, we need to make sure to cube that unit, but that means we have to cube the prefix as well. So the 10 to the negative 2 is going to be cubed. Centimeters will be cubed and 1 will be cubed. Everything is cubed. Now you can cancel out the units. Meters cubed cancel out, and we are left with centimeters cubed on top and 10 to the negative 6 on the bottom. We don't want to leave a negative exponent in the denominator, so it becomes a positive exponent in the numerator. 10 to the 6 centimeters cubed, that is what 1 meters cubed is equal to. In general, you don't have to memorize conversion factors. They are provided on the equation sheet. You just need to know the prefixes that we discussed earlier. Last topic is significant figures. You want to know how many sig figs are in a certain number. The first rule is that all non-zero digits are significant. For example, if you have 3,425, these are all non-zero digits. They are all significant. You would have 4 sig figs. Next rule. Zeros between non-zero digits are significant. For example, if you have 30,425, now this 0 is significant because it's between non-zero digits. So you now have 5 significant figures in this number. The hardest rule is probably the last one. Zeros after a decimal point and another significant figure are significant. The 0 has to follow both of these rules. For example, 0.00020. This 0 here is after the decimal and after another sig figs, so this 0 is significant as well as the 2. However, these zeros here before the 2, they are after a decimal, but they're not after another sig fig, so they are not significant. So this number only has 2 sig figs. And finally, if we are multiplying, dividing, adding, or subtracting numbers, we want to write our answer with the correct number of sig figs. If we're multiplying or dividing, we want to look at the number that has the least number of sig figs, and our answer has to have that same number of sig figs. For example, 0.0860 times 100.05. Plug that in your calculator, you're going to get 8.6043. However, that does not have the correct number of sig figs. Look at the first number, it has 3 sig figs. Look at the second number, it has 5 sig figs. So that means that our answer has to have 3 sig figs. So we're going to write 8.60. That would have 3 sig figs. That's our final answer. Adding and subtracting, we're looking at the number of decimal places here. Our answer has to have the same number of decimal places as the number that has the least number of decimal places. So the first number, 36.050, has 3 decimals. The second number has 0 decimals. That means our final answer has to have 0 decimals. If we plug this in the calculator, or just inside our brain, no calculator needed, we get 196.050. But we cannot have any decimal places because this number did not have any. Therefore, this is going to round to 196. And that's it, folks. That was the Chapter 1 review video.